Scanners have been around for a while, and they allow us to scan photos and documents into digital versions that are a lot less susceptible to damage over time. But what if you wanted to digitize the memories of something that wasn't 2D? Well, in this video I'm going to show you one possible method of scanning 3D objects and saving them to your computer. In order to do this project, you're going to need a few tools first. You'll need a computer, printer, and a webcam, as well as some white foam board. And the size of the foam board depends on the size of the object that you're wanting to scan. Lastly, you'll need a laser that shines a line instead of a point. If you don't have one, you'll need to order one online, or you can take a regular laser pointer and shine it through the stem of a wine glass. Now we need to download some free software found at this website. Just click on Downloads from the menu and select the newest version of the software to download. And go ahead and download and install it on the computer that you want to use as the scanner. If you go to the Start Programs David Laser Scanner folder, you'll see a folder called Printouts. You'll see the scales 30, 60, and 100 PDF files. The scale you choose depends on the size of the object that you want to scan, with 30 being for objects around 4 inches and 100 being for objects closer to a foot. You'll want to print the A4 version of the file because A4 is a standard paper size. And once it's printed, cut it along the designated line. Now on the back side of the foam board, draw a line down the middle and score it with a knife. This will create a hinge-like effect for the white side. Tape the markers on either side of the fold so that they are perfectly lined up when the foam board is folded. You want to minimize the visibility of any creases or gaps between the papers. Next, fold the foam board to a 90-degree angle, and to ensure that the angle is correct, use something that has a 90-degree corner, like a small book or a box. Then set your webcam in front of it and run the David Laser Scanner software. Now click Next. Select your webcam from the drop-down menu and you should see a preview of the webcam in a new window. You want to adjust the camera so that you see the marker in the center of the webcam. Depending on how close or how far the dots are from your camera, you can adjust the calibration point scale. This will put red X's on the preview so that you know where to position your marker. When you're through, click Calibrate Camera to calibrate it. If it fails, adjust the camera settings by pressing the Settings button and try it again until it passes calibration. Then click Next. Now place your object in the middle of the marker's dots. If it's not high enough, use a stand to boost it up. Then use your line laser to scan down the marker at a slight downward angle. The preview on the computer should start detecting the face of the object. Do this as many times as you think is necessary. Then when you're through, click Pause, and then in step 2 select Show Camera Image and then click Grab. This creates a texture image. Now if you click Show 3D, you'll see what you've scanned. Use the left mouse button to pan, the middle button to zoom, and the right button to rotate. Then you can click Save to save it as a .obj file to your C drive. As I'm sure you've noticed, so far we've only scanned one side of the object. So now you can rotate your object slightly and go through the scanning process again. Just click Erase and Start at the top to restart the process. Do this until you have the entire object scanned, making sure that each time you save it before starting another one. For testing purposes, I've only done 3 scans. If we had the full version of the David Laser Scanner software, we could then click Next and delete scan reflections and adjust each scan so that it makes a full 3D object. But unfortunately, you have to pay for the full version of this software to get those features. But luckily, we can do something similar using Blender. Blender is an open source 3D editing program that you can download for free from here. If you download and install it, you can then import the .obj files that we saved by going to File, Import, Wavefront.obj. Then browse to your C drive and select the first scanned file. Before continuing, it might be helpful to watch my Blender Basics tutorial that you can find here. First, right-click on the cube and hit Delete on your keyboard to delete it. Then right-click on the scan that you imported. Scroll the middle mouse button to zoom in on the object and press the middle mouse button to rotate around it. Now from the toolbar at the bottom, select Edit Mode. it should turn your scan into a wire mesh. Now hit A on your keyboard to deselect everything. Then hit B twice on your keyboard, and while holding down the left mouse button, select the points that you want to delete. Then right click on any of those points and hit delete on your keyboard. Select vertices and then hit enter. Continue this process until you've deleted all of your unwanted points while using the middle mouse button to rotate and zoom around the object. Once you've got it the way you want it, you can switch back to object mode and import the next scan to the scene. Use the same process to remove any excess scan points. When you're through removing stuff in edit mode, switch back to object mode and line it up with the first scan. You can do this by pressing RX or RY or RZ on your keyboard to rotate it on the X, Y, and Z axes respectively. And you can press G to grab it and move it into position. Do this until you have all of your scans imported, cleaned, and put into their respective places. Then you can hit F10 on your keyboard to select your output settings and hit F12 to save an image, or Control F12 to save an animation. Also, be sure to save the project by going to File and Save. Though my finished product looks a little rough, you can use this method to add perfect detail to your scans. You can find some example scans here. Overall, it can be a monotonous process, but this is an excellent cheap alternative to paying hundreds or thousands of dollars for scanning an object in 3D. If you guys have any more tips, feel free to leave them in the comments below. Also be sure to check out Tinkernut on Facebook and Twitter. Alright, that's it for this tutorial. For more, go to tinkernut.com.